Welcome to another lecture in the design of concrete members. In the last lectures or in the previous sessions, we have discussed how to design the beams. We have discussed only the design of beams against the bending moment, not for shear. So now in this topic, I will discuss how to design the beams against shear. So whenever we analyze any beam, we draw the shear force diagram and the bending moment diagram, and against the bending moment diagram we provide the longitudinal reinforcement that we have discussed in the previous lectures. And now I will discuss how to provide the stirrups or ties in the beams against the shear force. Okay, here is the cracking pattern shown for the shown in the beam. Okay, here that is a one end that is simply support, and on other side that is a continuous beam. Okay, and as you know, the bending moment is maximum at most of the time at the center of the beam, so that's why here you see the cracks at the center. As the cracks going to the spot, they are going to become inclined. Okay, so in general, the cracks which are developed due to the bending moment, that are called pure flexure cracks. Okay, so when you go at the spot, there is shear force is maximum, so that's why cracks appear inclined. Okay, so that cracks are called pure shear cracks, and in between the bending flexure cracks and the shear cracks, that are called shear flexure cracks or shear bending cracks. Okay, and you have seen in the bending cracks that originate from the bottom fiber of the beam, and the shear cracks that start developing from the center of the beam. Why is that so? Because when we draw the stress profile of the bending stress, that is maximum at the edge of the beam and the minimum at the center of the beam. That's why the crack originates from the bottom fiber. And in the shear stress, when we calculate the shear stress, we see, for example, in the rectangular section, the shear stress is maximum at the center and minimum at the edges. So that's why the crack originate in the shear stress at the center and try to propagate towards the outward. Okay, so in the previous classes in the structure mechanics or the applied mechanics, you have seen what is shear force. Shear force is the force which try to slide the section. Okay, we try to split the section, and the shear force acts parallel to the cross section. Okay, area of cross section. So now I will move further. Here is the formula for the shear stress calculation, and here I have shown the shear stress. Okay, so here that is again how the crack propagate in the beam due to shear stress that is maximum at the center, that try to pull by the forces, and the cracks start to propagate at 45-degree angle at the spots. Okay, so this is theory. In this topic I briefly try to cover the design of shear, so that's why I will skip some topics and go for the design. Okay, so I will briefly discuss some topics like what is concrete shear strength. Okay, due to the compressive strength of concrete has the property of the shear strength. Okay, so what is the, for example, the here is the concrete compressive strength, that how to calculate the concrete shear stress. Okay, so under root fc prime, and the allowed by the ACI, that is 8.3 megapascal. Okay, so whatsoever the concrete strength you have, you will take the under root. Okay, you will get the approximately the concrete compressive concrete shear stress, that is the VC. That is the symbol for the concrete shear stress. Okay, so whatsoever the applied moment and the applied shear force, we go for designing for that part. So I will go the next. Here is a longitudinal reinforcement. Okay, if in the beam there is more longitudinal reinforcement, then there is less chance of shear cracks. So that is the relationship. Okay, so if you have a more longitudinal reinforcement, means more steel ratio in your beam, so there will be you will get the more concrete shear strength, so that will in the resultant try to resist the applied shear, and in the further that also control the concrete cracks due to shear. Okay, if you have the more steel, then due to the concrete shear strength, that crack will also controlled by the concrete capacity. Here is a how to calculate the concrete shear capacity. So that is the formula ACI code provision for concrete shear strength, okay, or the shear capacity, that is VC as per ACI. VC equal to 0.16 lambda. Again, I will discuss the formula in detail while I will do the example. That is the SI System International formula, that is the FPS system. Okay, this formula is used when the axial force is minimum or negligible, and if there is a axial force present, that just like in the frame member, then the concrete capacity formula or concrete strength formula is this one. Okay, now shear strength provided by vertical elements means by two elements shear strength is provided. One is due to concrete and one due to steel. We will discuss again in the example in detail. Okay, here are different type of ties that is provided to resist the applied shear. Okay, we provide this in the concrete sections to increase the shear capacity, okay, to resist the applied shear. And the strength reduction factor for the shear strength of the concrete means on the material, that is 0.75. just like we did in beams for the tension control 0.9 and for other etc. So similarly for shear the phi factor is 0.75. That is a minimum web reinforcement. VU symbol is for the applied shear and VC symbol for the capacity. When we multiply with the factor, then we will get the design shear strength. And if applied shear is less than the shear capacity of the concrete, theoretically no web reinforcement is required. But in the code there is provision. However, if VU applied shear is greater or equal to half of capacity, means if we reduce the capacity by 2, again the code requires the provision of minimum area of web reinforcement. Means if your applied shear is greater or equal to half of the capacity of the concrete shear capacity of the beam, then at least minimum web reinforcement should be provided. The tie reinforcement, stirrup reinforcement is also called web reinforcement, AV minimum. Okay, so that in case if there is no applied shear is so less against the capacity of the section, then at that time minimum reinforcement must be provided as per ACI, that is the criteria. Location of maximum shear for design, the we provide first of all I will show the figure. Here is the beam, here is the shear force diagram. We calculate the applied shear at the distance D, effective depth distance D. Okay, and then we calculate the applied shear and then we go further for the design of the against the shear. So that is the location, okay, that is discussed here in this at a distance D, that is distance D is effective depth of the section. And here minimum section for design shear, that is a check. If the applied shear okay, according to ACI, if required shear to be resisted by transverse steels, means the steel which you have provided in the beam as a tie or stirrup, okay, so that definitely have some strength. Okay, this transverse steel Vs if exceed by this value 0.66 under root fc prime bwd. If your value of Vs exceed this, then you have to revise the section. This cross-sectional dimensions must be increased. Okay, and if less than this, then you have to go for the procedure for the providing like what will be the spacing, what will be the dia. Okay, and here that is already discussed, and here is a maximum spacing criteria. So when your Vs the strength provided the shear strength provided by the stirrups or ties, that is Vs, does not exceed 0.33 under root fc prime, the following criteria must be followed for the spacing. First criteria, AV FYT over 0.35 BW. That is again I will discuss in detail in the example. The second condition is D by 2. The third condition is 600 millimeter. That is smaller of the following, that is the S max criteria, means maximum spacing of stirrups or ties whatsoever will come from here. And if your value Vs exceeds 0.33, then the second and the third criteria will be half, means this will become D by 4 and this will become 300 millimeter. The maximum spacing as given by the second and third above conditions must be halved. Okay. Design of web reinforcement. Okay, the applied shear is resisted by two elements, means the concrete capacity whatsoever the concrete section is there, that is also resisting the applied shear, and second the steel reinforcement in the form of ties or stirrups. These both elements are resisting the applied shear. Okay, so how we will design the reinforcement for the ties, that again I will discuss in detail in the example. Here is a hanger reinforcement. For the placing and holding of the ties or the stirrups in the beam, we have to provide the hanger bars that are most of the time are called top bars. Typical shear force diagrams of shear force are drawn similarly as we have drawn in the structural mechanics. Okay, here is a typical diagram is shown. If there is only one beam, then the maximum shear that will be omega L by 2, omega L by 2, and if there is a continuous beam, then in the first exterior panel the shear force diagram will be calculated like this. On the left end that will be omega L by 2, and on the right end of the exterior panel 1.15 omega L by 2. Okay, these are the approximate values also given by this author. That is the steps for the design of general procedure for the shear design. Okay, when I will show you the example for the design, I will discuss in detail the steps.